everyone. My name is Zishan, and today we're going to look into February-March 2026 additional math paper 2-2. So the first question that we have here is about quadratics, which is usual for them. It's always supposed to be something related to range and domain of functions. Okay, and this here is a quadratic question, and completing the square form is a very common thing they do. So let's see. There are a whole set of steps that you would want to do. First, you want to take a 2 out common, and from every term here. So you go 2x squared minus 3x plus a 2, and then you introduce two terms plus a 3 divided by 2 square minus a 3 divided by 2 square plus a 2. You see, if you have a 3 there, I'm going to go 3 by 2 on these two terms by myself, which are actually going to cancel out to a 0. So I'm not changing the values of the quadratic. I'm just introducing two terms. And why? Because I want to reach a form. This here reduces to a perfect square. So you go 2 and reduce them to a perfect square x, a minus and a 3 by 2 square minus a 9 by 4 plus a 2. One common area of mistake is not writing a minus here when there is a minus there. Okay. And then we go simplified 2 times x minus 3 by 2 squared minus this turns out to be a minus 1 by 4 and this thing. And then you go to open up this bracket and you get 2 minus x 2 multiplied by x minus 3 by 2 minus a 1 by 2. Another area of mistake, 2 multiplies with 1 by 4, it becomes a 1 by 2. Okay? So these are a few areas, and that is your final answer for this much of it. Okay. Now, again, one of the reasons why completing the square method is important because it tells you a lot about a quadratic. And range of it is a very important thing that you can bring about from the square form. If a times x plus b whole square plus a c is the form that you've brought the quadratic to, know that a greater than 0 means that the quadratic is always going to be greater than equal to c. And when a is negative, f will always be, the function will always be lesser than equal to c. Also know that minus b comma c is going to be the vertex, and in this case, a minima. And in this case, again, it's going to be a minus b comma c, and it'll be a maxima. The quadratic here is going to be upside down, and the quadratic here is going to be this way, carved upwards like that. Okay. So this tells you the range. A here, that's A. It's positive. So of course the range of it is going to be greater than equal to negative 1 by 2. Okay. Now here, a function g is defined by that for x lesser than equal to k. Zoom in a little bit. Given that g has an inverse, state the largest possible value of k. Okay. See, there's something I know about quadratics. There are naturally many one functions. If you want to have an inverse of a quadratic, you're going to have to restrict the domain of it. One very easy approach to do that is to get the vertex, let's say it's h comma k, restrict the domain of this quadratic in a way x is always greater than equal to h. So you're only looking at this part of the curve. Okay, so when x is greater than equal to h, this is the only part of the quadratic that remains. You've restricted the domain. This part is a 1-1 version of it, which means it is invertible. Or you can also go keep x lesser than equal to h, and you're only going to be remaining with this part of the curve, which is also a 1-1 thing. So let's go back to the question and see what do they want. They want this thing to be invertible for x lesser than equal to k. Well, I already have the square form of it. There it is. 2 times x minus 3 by 2 square minus a 1 by 2. I know that the vertex of this quadratic is going to be at 3 by 2, comma a minus 1 by 2. Now, if this is the vertex, for the function to be invertible for x lesser than equal to k, x should be lesser than equal to 3 by 2. This is the one, x lesser than equal to h. In this case, the x coordinate of the vertex is a 3 by 2. That is why x lesser than equal to 3 by 2 is how it is supposed to be. But pay attention, they wanted you to tell them the value of k. So k is a 3 by 2. That is your answer. Okay. Now let's look at this one. A function hx is e to the power of 3x minus 1. Given that GHX exists, find GHX and simplify your answer. Okay, so I know GHX is nothing but the HX substituted into GX. Wherever I see X on GX, I'm going to substitute it with this whole thing. This whole thing. Okay, so let's go. Uh, it's going to be 2 times e to the power of 3x minus 1 squared minus a 6 times e to the power of 3x minus a 1 plus a 4. And I'll open up these brackets. So it's going to be 2 times e to the power of 6x minus 2 and minus a 6 times e to the power of 3x minus 1 plus a 4. Oh, there is a mistake that I've made here in the way I write hx. So, like I told you, there are many places one may go lose marks. It was not e to the power of 3x minus 1. It was actually e to the power of 3x minus a 1. And now GHX is going to be 2 times e to the power of 3x minus 1 whole squared minus a 6 times e to the power of 3x minus a 1 plus a 4. Now we're going to go open up the bracket. So GHX equals 2 times square of this term, first term, e to the power of 6x minus 2 e to the power of 3x plus a 1 minus a 6 e to the power of 3x plus a 6 plus a 4. Let's open up this bracket. 2 e to the power of 6x minus a 4 e to the power of 3x plus a 2 minus 6 e to the power of 3x plus a 10. And you are looking at 2 e to the power of 6x minus a 10 e to the power of 3x plus a 12. Well, this is what it looks like to me. And that is correct. Okay, so one thing you would want to keep in mind is when I square this, the first time I get, see, I've used a minus b square formula. A square minus 2ab plus a b square is what you get. Remember, e to the power of 3x when squared is e to the power of 3x multiplied by 2. Well, that's e to the power of 6x. See that? Okay. So that is how you want to go about this question, and that's your answer. Let's go to the next one. Okay. Perpendicular bisector, again, a very, very common kind of a question. And they ask this a lot. Let's see. Points A and B have coordinates. The point P with coordinates lies on the perpendicular bisector. Well, first thing I'd do is I'm going to go find out the equation of the perpendicular bisector. Okay. I know that the points are 1, 3, and minus 7, 1. I'm going to find out the midpoint of it. Midpoint of AB. I'll use the formula x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. Well, in that case, it comes out to be 1 plus a minus 7 divided by 2, comma 3 plus a 1 divided by 2. And it comes out to be negative 6 by 2, comma 4 by 2, which is a negative 3, comma 2. That is your midpoint. Now I'm going to go find out the gradient for AB. Gradient is going to be y2 minus y1 divided by x2 minus x1. And I go 1 minus 3 divided by minus 7 minus 1. And it's a minus 2 by minus 8. It's a 1 by 4. Okay. So if this is the gradient of AB, the gradient of the perpendicular bisector, gradient of the perpendicular is going to be the negative reciprocal of 1 by 4. That's negative 4. So M for the perpendicular is going to be minus 4. Okay. Now I have the M value of it. And I also know that this perpendicular bisector of AB has to go through the midpoint. So I have one of the points it passes through. I'm going to use that. So I go y equals mx plus c is the equation. It's usually this equation. Y for this point is a 2. M, you know, is a minus 4 for this perpendicular bisector. And then x is a minus 3 and plus a c. So I'm going to go find out c from here. C comes out to be 12, 2 minus 12, that's a minus 10. Okay. So now you have the equation of the perpendicular bisector. I will write it with a different color for you not to get confused. Y equals minus 4x minus a 10. That is your perpendicular bisector. Okay. Now, let's look at the question. Well, they say there is a point 2 comma A which lies on this perpendicular bisector. Find out A. Okay. If y equals minus 4x minus 10 is the equation of the perpendicular bisector, the coordinates of 2 comma A, these coordinates should fit into this equation. In a way, when y is a, x is a 2, and that gets you to the value of A, it's a negative 18. And that is your answer for it. A is a negative 18. Okay. Now this here, look at the part B. It's a question which has recently floated into the scene. Um, it was not that common earlier. Nowadays, for the last 3 or 4 years, this is a go-to question for them. Let's see. They say there is a point Q, which is the reflection of P in the line AB. Okay, so that's your line AB. Let's say P is somewhere here, 2 comma negative 18. That's P, and that's AB. Q is the reflection of P. So it's going to be somewhere here about that lines, right? Q is the reflection of P about that line. So it's going to be somewhere here. We're going to have to find out the coordinates of it. And you know that the midpoint of a, AB, is a negative 3 comma a 2. Okay. So the basic approach for this one is to know that if Q is the reflection of P, this distance is the same as that distance, which means negative 3, 2 is the midpoint of PQ also. So we're going to use the midpoint formula. Negative 3 is supposed to be x of Q plus x of P divided by 2, which gets you to x equals negative 8, and y of the midpoint is supposed to be y of Q minus a y of P, y plus minus of P, y of P divided by 2, and that gets you to y equals 4 plus 22 there, minus 8 comma 22. Those are the coordinates of Q, minus 8 comma 22. Okay, so the last time I was on this paper, I actually sketched the situation. I would want you to see if these two are A and B, this happens to be the negative 3 comma 2 point, and there's P and that's Q. When P is a 2 comma minus 18, Q happens to be negative 8 comma 22, and that is your answer for this question. Okay, let's go back and see, there it is. That was the question number 2. Let's go do question number 3 now. Okay, again a standard cubic sketching kind of a question. They're like, draw a suitable line on the diagram and solve this inequality. The cubic is greater than 7. Okay, so the way you want to approach these questions is you draw a straight line, horizontal straight line at 7 on the y-axis. Okay, and let's see, we're gonna go draw a straight line there. Let's see. Yeah, that looks like 7 to me. There, that's the line. Let's go do a thicker one. Yeah. Okay, now I want the cubic to be greater than 7. So you are looking at this region of the cubic. The way is to read the coordinates carefully. There is a mistake that people do, although they understand. So when a question seems to have come about for you, when you feel like it's easy, you tend to do mistakes. You tend to rush through it. So you would want to read the coordinates properly and calmly. Okay, so let's go. I'm going to read the coordinates of these points. Okay, so there's this one, and this one. Okay, so let's see. This one falls down to somewhere there. This one looks like it's somewhere here. And this one, let's bring it like that. Okay. And this one seems to have come down to some point like that. Okay. So we're going to go read them now. Let's see. Okay, so this one looks like it's negative 1.3. There, that's negative 1, 1.1, 1.2, 1.3, negative 1.3. And this one looks like it's a negative 0.2. And this one is the other one. The other one on the right is supposed to be, that's 3, 3.1, 3.2, 4, 5, and 6. 3.6. That's what it looks like. Let me zoom in a little bit and see. That's a 3.1, 2, 3, 4, 5. Oh, that's a 5. So there it is, 3.5. Now you want the curve, you want this part of the curve above the 7 value and this part of the curve. So you go keep x between these two and to the right of 3.5. So your answer is going to be x lesser than negative zero point 0.2, greater than negative 3.1.3, and x greater than 3.5. That is your answer for it. Okay. You go x lies between negative zero point 0.2 and negative 1.3 and x greater than 3.5. The common mistake here is to read the coordinates wrong. Okay, so that was the third one. Let's go to the fourth one now. Okay, now permutations and combinations. See, there are a lot of ways people can solve these questions. I'll try to cover as many ways as I can. Okay, and the final answer should be the same. Okay, uh, you have 9 digits given to you: 1, 2, 3, 4, 5, 6, 7, 8, 9, and you want to create a 6-digit number out of it. And how many numbers can be created if there are no restrictions at all? Well, I'll go out of those 9, I'll take 6 and count the number of permutations possible. 9p6. That is my um, answer to this one. Number of permutations of 6 digits taken out of those 9. Okay. So that was your, and this actually comes out to be 4032. Oh, sorry, 60480. 60480. That is what it will come out to be. Yeah. Okay. Now, one mistake here is people forget it's a permutation question and not a combination question. People may go 9C6. That's wrong. If you actually want to choose only 6 digits out of 9, well, in that case, you're going to have to multiply by a 6 factorial to get to the correct permutations possible. This and that, same value, 6480. You choose 6 out of those 9 and do 6 factorial permutations on them, or you simply go write a 9p6. These two are actually the same two things. Okay. Now, they say number of 6-digit numbers in the part 2, they include a 4 for sure. The 4 has to be there. Okay. Well, there are many, many approaches of it. Well, what I would want to do in my attempt of it is go take 5 digits out of those remaining 8, because 4 is always going to be there. So I've got 1, 2, 3, 4, 5 digits out of those 8 and the number 4. And then I'll do 6 factorial permutations of them. So 8c5 into 6 factorial. That is what I would like to do. Another approach. That is my answer of it. Okay. Another approach. What they do is, what they may want to do is take all the permutations that you have found out here and all the permutations without the 4. So 8p6 and subtract them. What is it? These are with no restrictions at all. 4 may or may not be there. These are with no 4 at all. No 4. 4 is not there. So only 8 numbers to choose if 4 is not there. 6 numbers to choose to create these permutations, 8p6, subtract them. All you're going to remain with is the permutations with 4 there. And that is another way of doing it. I have seen them do a different approach also. I'll tell you what it is. Let's say you know you have the 4 there. Okay. So you go, there are supposed to be 6 positions that 4 can occupy. 1, 2, 3, 4, 5, 6. 6 positions that this number 4 can occupy. So what you do is count the number of permutations there are for 5 digits chosen out of those 8 and multiply that by a 6. That again is the same value. So what is it? Take 5 digits out of those 8 remaining, because 4 you've already chosen. There it is. With every permutation of these 5, you know there can be 6 spots that 4 can occupy to give you a new number. So that is also an answer. With all of these, what you get is a 40320 with all of them. 8c 5 into 6 factorial. That is what I did the first time I went through this paper. And then there was this thing, 8p 5 into 6. I was looking for alternate solutions. This is what I found. And there is, again, a very comfortable one. This one is very comfortable one. I take all the permutations with or without the 4. These without 4, subtract. And that is how you end up with a 40320. Okay, now let's look at this one. Again, this one also has multiple ways to come to the answer. Okay, let's see. So a class contains 10 girls and 12 boys. A group of 6 students is to be selected from the class. There must be at least 2 girls and at least 2 boys in the group. Okay. So I'll lay out the scenarios which favor the outcome. 2 girls and 2 boys at least. Okay, so how about we go one group with 2 girls and 4 boys? How about 3 girls and 3 boys? 4 girls and 2 boys? Well, that seems to be all there can be. Can we have 5 girls and 1 boy? No. Can we have 5 boys and 1 girl? No. Okay, so these are the 3 outcomes there can be. And then I'm going to go count the number of ways these can come true. So this one with 2 girls and 4 boys, these are all the scenarios there can be. Okay. So you go calculate the number of ways this can come true. Well, 2 girls out of those 10. You go 10C2. Well, this is a combination question. You're choosing people out of a group. Okay. Multiplied by 12C4. Okay. What about this one? So you go 10C3 multiplied by 12C3. This is a 10C4 multiplied by a 12C2. Okay. Now there are multiple scenarios which can favor the outcome. It can be this or that or this. Whenever you have multiple scenarios with an or in between, like this or that, that's where you add the outcomes to get to the final answer. So you're supposed to figure out all of these and add them. Okay, that is how you would want to approach this question. Sometimes people multiply them, okay, do not add, and there are many other mistakes people can do here. So this finally would come out to be, let me see, a 62535. When you add them all, 62535. Okay. Okay. Other approach for the same question is what we do here, what we did here. Elimination, this one, elimination. I eliminate all the situations were where there were not two girls or two boys in the group. First, no restrictions. So let's write it in a different color again for you not to get confused. So no restrictions. 22 people, choose 6 out of them. 22 say 6 is what you do without any restrictions. What if there were there was one girl and 5 boys? Doesn't favor the outcome. What if no girls at all and 6 boys? Again, that's what we wanted, and this is where we are. Doesn't favor, so we're gonna count these. Okay. Another situation where there is one boy and 5 girls, no boys and 6 girls. There, all of these, and we're gonna go count them. One girl, 5 boys. No girls, 6 boys. One boy, and there. And like I told you, we're doing elimination here. So from no restrictions, I'll remove the ones with this kind of a situation. I'll add them all, and remove them from the whole lot. There. This plus this plus this plus this. Remove them from 22.6. You will also end up with a 62535. Let me bring in the numbers they would come to. Let's see. Okay, so this is a 12078. These add to a 12078. And that is a 74613. And when you subtract them, this is your final answer. Okay. So that was your answer for the part B. Okay, let's do the fifth one now. Okay, circular measure. Okay, let's see. ABC is an equilateral triangle. Okay. Arcs BC, CA, and AB are parts of the circles with centers at A, B, and C. Write down the size of the angle in radians. Well, if it's an equilateral triangle, of course, all the angles that you have there are going to be 60° or pi by 3 radians each. If they want me to tell them ABC, well, that's going to be a pi by 3 radians. Okay. Now they say that the area of the badge is 2 times this. Find out x. Oh, that length. X, this length. Okay. So what I do is I take this diagram to the right and zoom on it. Okay. There. And when they've already told the area, it's a 2 times pi minus 3. Okay. So this is the area they're saying it is. Find out x, this length. Okay. Let's see. Well, I can find out the area of this equilateral triangle. The formula for area of equilateral triangles is always root 3 by 4 into the length of the side squared. Well, that is your triangle. That's what I know about the triangle. I can also find out the area of these segments, which are all equal, by the way. And I'll add these segments, three of them, to the triangle to get the area of the badge. That is my approach. So I'm going to have to find out the area of the segment there. I'll find out one and I'll and multiply it by a 3 to get these regions and add that to the area of the triangle. That's what I'm going to do. And it should come out to be this. Let's see. That's what I know. And we go uh, find out the area of the segment. Well, that segment is going to be, let's call it segment number 1. Segment 1 is going to be the sector ACB minus the area of the triangle ACB. Remove the triangle here from the sector, this whole sector. Let me be a little more clear here. You go, that's a triangle. Remove that triangle from this sector, this whole thing. What you remain with is just that segment. Okay, that's what we're going to do. Let's see. So area of the sector is going to be 1 by 2 r square theta. Ah, the radius of the sector is x. This sector has a radius of x. So I'm going to go 1 by 2 r square theta, pi by 3. This angle is a pi by 3 minus area of that triangle, root 3 by 4 x square. Okay, let's simplify this now. Hmm. So it comes out to be pi x square by 6 minus a root 3 by 4 x square. That is the area of the segment. Now 3 times that, come to a pi x square by 2 minus a 3 root 3 by 4 x square. That is the 3 times the segment thing. Okay, so where am I right now? Well, I've found myself areas here. All 3 of them. I'm going to add these 3 to the triangle. Okay. So let's do it here. The 3 segments plus, these are the segments, plus the area of the triangle. Well, that comes out to be pi x square by 2. Now there, these 2 can actually be reduced to a 2 root 3 by 4 x square. And what do we want these to come to? This area should be equal to what they've already given. There, this. Okay, so we will equate it to 2 times pi minus root 3. And let's see. I'm going to take pi x square by 2 minus that 2 and 4 cancel out. So root 3 x square by 2. And that's a 2 times pi minus root 3. Okay. And I take x square by 2 out common. So pi minus root 3 equals 2 times pi minus root 3. Okay. And that is how I get these cancel out. X square by 2 is a 2, which means x square is a 4, which means x is a plus minus 2. But you know that it's the length of the side. There's no point of it being negative. So x equal to 2 is your answer for this question. Okay, so that is it for 5 marks, x equal to 2. That's it. This is your entire solution. Mm, yeah. Okay. Okay. Now that was the fifth one. Let's go to the sixth one now. Okay. The period when the y is equal to this. Well, I know if y is a tan of bx plus a c, I know that the period of it will always be pi divided by b. Okay. So what we have as y here is tan of x by 2 plus a 1. Rewriting this as that. And from comparison, I see a is a 1 there, 1 multiplied by that. B is what we have with x. With x there, I have a 1 by 2. And C is a 1. And that is how, so there's a very common place, pi by B. B is a 1 by 2 in this case, okay? For us to recognize. B is a 1 by 2. What you have with x is a B, and what you have with x here in the expression is a 1 by 2. So period is gonna be pi divided by 1 by 2. Well, that comes out to be a 2 pi. Okay. So that is your period for this thing for 1 mark. And then the equation of the asymptote. Okay. Let's see. Well, again, if y equals a tan of bx plus c is the equation of a tan curve, remember the first vertical asymptote. The first vertical asymptote. What do I mean when I say first vertical asymptote? Well, if this is your y-axis, the first asymptote I call this one the first one. This one the first one, the one which is right next to the y-axis. The first asymptote that the curve comes across when you go to the right of the y-axis. Okay, that's your first asymptote. I know that the first asymptote is always going to be x equals pi by 2b. If you go to the right. The second asymptote is going to be x equals 3 pi by 2b. The one to the left is always going to be negative pi by 2b. And if you go further on the left, it's going to be negative 3 pi by 2b. So the point is, asymptotes are supposed to be odd multiples of pi by 2b. X equals pi by 2b, 3 pi by 2b, 5 pi by 2b, 7 pi by 2b. That's what it is supposed to be. Now, asymptote A is the second one. If you go from the y-axis right, of course, it's going to be this one. And that is why the asymptote is x equals 3 times pi by 2b. There it is. It's basically a 3 pi. And that's about it. That is your answer for this question for 1 mark. Okay. So when you go sketch this curve, tan of x by 2 plus a 1, you'd see that the blue one is the first asymptote. There it is. And the green one is the second asymptote, x equal to 3 pi. That's the one they asked for in here, the second one. Hmm? One added thing you would want to keep with you. Remember this line. The principal axis for this curve is going to be y equal to 1. It's always supposed to be this thing, y equal to c. This is the principal axis when it comes to a tan of bx plus c. Okay. Okay, so that was 1 marker. Now they want you to sketch. Okay. 3 cos of 2x plus 1. That's question number 6, part B. Okay. 3 cos of 2x plus a 1. Again, we have a set method for these things. If it's a cos of bx plus a c, I know that the principal axis is going to be y equal to c. I know that the period is going to be, if it's a cos curve, the period is going to be 2 pi by b. It was a pi by b for a tan curve. For a cos curve, it's a 2 pi by b. And I know that the amplitude is going to be an A. Okay, so these are the things I will start with. First, I'll go look at the y equal to c, the c value. C value is a 1, so y equal to 1. There is your principal axis. And period is at 2 pi by b. I'm going to go look for the b value. Well, b is what I have with x. It's a 2. So it'll be 2 pi divided by 2, a pi in this case, or a 180 degrees basically. Radians. Now, what does period mean when you are sketching a curve? Well, you know you're going to have one entire wave stretched over 180 degrees on the x-axis. That is what it means. If this is 0 to 180, this thing, you'll have one entire wave. So it's either going to be a sine curve like that. That's one entire wave. Or you can have something like that, something like this when it's a cos curve. Okay. One entire wave is what you're expecting to exist between 0 and 180, or 180 and 360, or a gap of 180 should be there. Okay. And amplitude in this case is the a value. A value here is a 3. So you're going to go do an amplitude of 3 on this wave. If this is the principal axis, you're supposed to go 1, 2, 3 units up, and 1, 2, 3, 3 units down from that principal axis. These are the lines the cos curve is going to go exist in between. Okay. Well, I know that a cos curve looks like that. That's what I know. Starts from the maxima at 0. If it's like a cos of bx plus c. Okay, so it's at this point. If it's a cos of bx plus a c, this point has to be a plus c always on a cos curve. Okay. Sine curve will do something else. A sine curve will go like this, this, and this point will be a 0 comma 0 if it was a sine of bx plus a c. Okay. So we go start from here. That's the maximum point. I know you're going to have one entire wave between 0 and 180. So I'll go mark up the places there. Mm. So roughly like that there and there. Okay. Same thing out here. Mark up the places on the principal axis. There. Okay. So touches the minima at 90 and negative 90 with the maxima at. So why did I come up with something like that? Well, I wanted the curve to have a maxima at x equal to 0. And I know that the period is a 180. So of course it's going to reach minima halfway through that 180. So at 90 it is. So I go, and that's basically uh, 45 degrees for you, these two. 45 and 135. So it's going to be 45 degrees. This is going to be 135 and so on. That you don't need to show that. Let's see if they have asked you to show something here. On the axis below, sketch the graph between 1 and 180. And that's your curve. Done. That was your question. Okay. Okay. Look at this one now. A ship is sailing with that speed. Find the speed that makes C a minimum. Optimization question. You want the cost per hour to be at its minimum. Well, I know dc by dv should be a 0 when c is a minimum. Okay. F, a function, is at its minimum when df by dx is a 0. Okay. And that is what I'm going to do here. dc by dv must be a 0, which makes me come to a 2v cube minus 3000 is a 0, or a v cube is a 1500, which means v is a cube root of 1500. I don't remember. I think it's 11.43 or something. Let me just check. Give me a second. Yeah, so it comes out to be 11.45 kilometer per hour. And that is the value of v for c to be a minimum. Now they're like, justify that this c value is the minimum. Okay, so I'll do the double derivative test. I will differentiate the c function twice. It comes out to be 2 minus uh, 6000 by v cube. For v being a 11.45, the derivative of the derivative, that second derivative, comes out to be positive. So it's a minima. That's your justification for it for 5 marks. Okay. And find the speed that makes C a minimum. Okay, fine. Let's go look at the next part. Hence, find the minimum sailing cost. Okay, for 150 kilometers. Well, if the velocity minimum was a 11.45, it'll take you a few hours to go through 150 divided by 11.45. That's the number of hours it's going to take you to go through 150 kilometers at the minimum, at the speed which gives you the minimum cost. Okay. 150 divided by 11.45. That's the speed you want to go at for the cost to be minimum. 11.45. Okay. And I know that every hour that I go takes me this amount of money. Okay. So cost per hour is equal to C, and it's given by V square plus 3000 divided by V plus 100. And let's see what it comes to. Comes out to be about 493.09 pounds, dollars. Okay. That's the cost per hour. How many hours have you actually spent? Well, 493.09 is the cost per hour multiplied by the number of hours you've spent. Okay, that is the cost, minimum cost. Now, see, there are many mistakes one can do here. What they have given is the cost per hour here. And what they have asked for is the sailing cost for the entire journey. So you should know, first you want to calculate the hours it takes to cover 150 kilometer at that speed. So there it is. And then you multiply that with the cost for 1 hour, the minimum cost for 1 hour of travel, cost per hour, $493 comes from this one. If you substitute a 11.45 here, you come to these many dollars spent per hour, minimum. And then you multiply that with the number of hours, you get the cost. Let me see what it comes out to be. It's a $6,487. That's the amount it will come to. Okay, so that was the seventh question. Okay, the eighth one. Let's see. There is a circle with a center and the radius. Well, right away, if this is the center and the radius is given. Well, first things first, if A comma B is the center of a circle and the radius is a R, I know that its equation is gonna be this. Okay, so I know it's gonna be x plus 2 square plus a y minus 0 square should be equal to 5 square. So you're looking at x plus 2 square plus a y square equals 25. And you're looking at x square plus 4x plus a 4 plus a y square equals 25. Okay. Now they say there is a line which does not meet the circle, doesn't meet the circle. Okay. Find the values of k. Well, I know to find out the points of intersection of a line and a circle, I always try to solve them like a simultaneous pair. So y is at 2x plus k is what I'm going to substitute here. Okay, so let's see. X square plus a 4x plus a 4 plus 2x plus k equals 25. Solving it like a simultaneous pair, take that y from the line and substitute it here. Okay. So you come to a x square plus 4x plus a 4 plus a 4x square plus a 4kx plus a k square, and it's a 25. And let's rearrange this. 5x square plus a x common out, 4 plus 4k plus a 4 plus k square equals 25. So you are looking at 5x square plus a x times 4 plus 4k plus a k square minus a 21 equals 0. Okay. Remember to take the 25 to the left. Okay. It's that's when you have a nice quadratic equation that you can either solve or go with for other details they would want. Okay. So k square minus 21 with a 4 and a 4kx. Okay. 4x. Okay. Done. 4. Okay. Yeah. Okay. Now, if the line does not meet the circle, it actually means that the discriminant of this quadratic you have is lesser than 0. That is what it means. Okay. So the discriminant of this quadratic must be less than 0. Let's figure out the discriminant. Well, that's your b value for the quadratic. That's your c value for the quadratic. And that's your a value for the quadratic. Discriminant is supposed to be b square minus 4ac. Okay. So it's going to be 4 plus 4k square minus a 4a into c, and it should be lesser than 0 for the line not to meet the circle. Okay, so you go 16 plus 32k plus 16k square minus a 20k square plus 420 is lesser than 0. And you're looking at negative 4k square plus 32k plus 436 should be lesser than 0. Well, a place where people do mistakes here. I want to get rid of that negative 4. I'm going to divide both the sides by a minus 4. Okay, that's what I'm going to do. So this becomes a k square. This becomes a negative 8k. And this becomes a negative 109. But the moment you divide an inequality by a negative number, the inequality flips. It becomes a greater than 0 now. And now I think we can go figure out the values of k for which this is equal to a 0. Okay, so how? How are we going to go use the quadratic formula? Minus b plus minus root over b square minus 4ac divided by 2a, and that's a 8 plus minus root of 64 plus a 436 divided by 2. That's a 8 plus minus root of 500 by a 2. That's a 8 plus minus 10 root 5 by a 2. That's a 4 plus minus 5 root 5. Those are the two values you get for k. Now, that's when the quadratic is equal to a 0. We'll come back to the inequality part of it. I'm going to do the number line method. And there, 1k value is a 4 plus 5 root 5. And the other k value is a 4 minus 5 root 5. So there it is, 4 minus 5 root 5. I know it's negative. 4 plus 4, 5 root 5. I know it's positive. And I'm going to go look for the critical value for which the inequality, this thing is true. But this should be greater than 0. This is negative number, this is positive, so I'm going to take a 0, and it doesn't work. So these are the two values of k. K should be greater than 4 plus 5 root 5. That's to the right. And it should be lesser than, that's to the left of 4 minus 5 root 5. That is your answer. Okay, so this and this is also known as the sign method. They call it the sign method. This is negative region, that's positive region, and that's positive region. That is why k should be to the right of this and to the left of this. That's our thing with the whole thing. That was your question. Very nice. Uh, when I attempted this question the first time, I did a few silly mistakes. I I forgot to flip. Well, you should not do that. And there was one more mistake, if I remember. Um, yeah, there. This 25 should be taken to the other side and it becomes a negative 21. I did not do that. So that was me. Um, that was my mistake. Anyways, let's go to the ninth one. Okay, trigonometric identities now. Prove that this is equal to that. Well, I'll convert everything into sine theta and cos theta. Sine theta by cos theta plus a cos theta by sine theta plus a 2 by cos theta. These three change to that. Now I'll take the LCM. LCM is going to be sine theta into cos theta. Now the numerator. For the first term, it's going to be sine square theta. For the second term, it's going to be cos square theta. And for the third term, it's going to be 2 sine theta. Well, I know that these are always a 1. These added is always a 1. So you go there divided by sine theta into cos theta. And that's a 3 marks. Done. And then they're like, solve this equation. Okay. Well, the part A serves as a hint for the part B. If this can be written as that, know that this can be written as 1 plus 2 sine of 2x by sine 2x and cos 2x. Okay? If there is a theta here, I end up with theta there. If there's a 2x here, I'm going to end up with 2x there. So these two are equal. So all I am looking for right now is the solution for this equal to 0. That is how I start. Because this is just that now. Okay. I'll take this to the other side. It multiplies with the 0. So you're looking at 1 plus 2 sine 2x is a 0. That means sine of 2x is a negative 1 by 2. I know that x needs to be between 180 and negative 180, which means 2x. I'll write it in a different color here. If x can be between these two, 2x can be between 360 and negative 360. That's adjusting the domain. Okay. Which means 2x being a sine inverse minus 1 by 2 gives you first two results. This is a calculator paper, so you can use your calculator. Sine inverse of minus 1 by 2 on the calculator will fetch you a negative 30 right away. If you get a negative 30 as the primary angle from the calci, the other one, the other angle when it comes to sine inverse will always be pi minus what you got there, or a 180 minus what you got there. In this case, 180 minus a minus 30 comes out to be 210. Okay. So as of now, I have got two answers, negative 30 and 210. Okay. Now, well, 2x can be as large as 360 and as small as negative 360. Well, I can go look for more possibilities. How do I do that? Well, from the basic angles that I got, I'm going to get the other possibilities. How? I'll add a 360 and I'll subtract a 360, literally rotating the angle by a 360 to make it come back to itself. If you rotate a thing by 360, you're actually coming back to itself, back to the angle. So negative 30, I'll rotate it with a plus 360 and a minus 360 to get more possibilities. And the same on the other one. Well, this fetches me, let's write it in a different color, 330. This is a negative 390. This is a 570. And this is a negative 150. Now I have 1, 2, 3, 4. 4 answers which are in the domain. So 2x is going to be negative 30, 210, 330, and negative 150. These are my answers. X is going to be half of all of these, negative 15, 105, 165, and negative 75. Well, these are your answers. Let me go check them. Give me a second. Oh, yeah, that is the correct bit. Okay, so that was it. Now, mistakes here. Mistakes is being able to figure out the correct angles. That's one mistake. And other mistakes is not going fetching more possibilities, more angles. That's another mistake. People usually stop it at that. And getting the correct angles. Everybody has their own way of figuring out these two angles. When you do a sine inverse of -1/2, you've got many ways of approaching it. Negative 30, of course, is gonna be fetched by the calculator. But the other angles, these, you have to have some method for it. Well, I can teach you my method of it, and you can see if it works for you. Not right now, in some other video, we will definitely go do it. You need to tell me if you want to learn how to do it. Okay. You may have your own way of doing it though. Anyways, let's look at this one. Part C, solve this. Okay. Well, x minus 1 is what I see, and x, the domain of it is given. Well, the first thing I do is adjust the domain. And if x lies between 3 and -1, I know x minus 1 will lie between -1 and 3 -1. That literally is -2 to x minus 1 to 2. So the idea to adjust domain is to subtract a -1 from all 3 to get our x minus 1 at the center. Okay. And what I do is I let x minus 1 be equal to a theta. So I'm looking at theta lying between -2 and 2. And the question now looks like 3 sec theta -1 equals tan square theta. Okay. I'll use the identity that tan square theta is supposed to be sec square theta minus a 1. So I'm looking at 3 sec theta minus sec square theta is a 0. I'll take a sec theta out common. is a 0. I get sec theta is a 0, and a 3 minus sec theta is a 0. Well, sec theta is a 0. There are no solutions. Sec theta will never be a 0. Hmm? 3 minus sec theta, no solution. You write it clearly. Cos theta is a 1 by 0. Not no solution is where you stop it. Okay. This one, which means sec theta is a 3, which means cos theta is a 1 by 3. And that can actually be solved for theta lying between 2 and minus 2. Okay. So let's go. Theta is going to be cos inverse of 1 by 3. And let's see what results we get. Give me a second. Okay, so the last time I did it is sec theta equal to 0 fetches result. So that is out of the scene. And cos theta equal to 1 by 3 comes to these two. 1.23 and 5.05. Let's do it. Okay. So from the calculator, this must fetch you a 1.23. Okay. Now, the point is, if you're doing a cos inverse and this is what you get as the primary angle, remember the other one will always be 2 pi minus that 5.05 it comes to. Well, theta needs to be between 2 and minus 2. Well, this one is in the domain. I can go as far as a negative 2 on the left of the, uh, uh, I can go to a negative 2 as a negative value of theta. So I'm going to go fetch more results. And again, I'll rotate them plus a 2 pi minus a 2 pi. Same on this. Like I did a plus 360 and minus 360 on the previous one. Plus a 2 pi minus a 2 pi. Well, this will not fetch me anything. It'll be greater than 2. This, again, it'll be lesser than minus 2, so no point. Adding, again, no point. But this one actually fetches me a negative 1.23. And that is how I know there is 1 and 2 answers. And theta comes out to be 1.23 and a minus 1.23. Well, that's what x minus 1 is for you. X is going to be 2.23 and a negative 0.23. Those are your answers. Okay. So a very nice question for 5 marks. This one method, no, if it is bugging you, if it's not making sense to you, you tell me. I'll go try my best to explain the entirety of it, this whole thing. As of now, I don't think I should include the whole thing here. Okay. And that's about it for this question. 2.23 and a negative 0.23. That's your x. Okay, let's go do more. The 10th one. Okay, we have kinematics now. Find the times when the velocity of the particle is a 0. Okay. Well, I know that the acceleration is given by 2t minus a 9. I also know that velocity is acceleration integrated. So it will be 2t square by 2 minus a 9t plus a c, which is a t square minus a 9t plus a c. They say that velocity is a 4 when time is a 7. Well, I'm going to use that to find out the value of c. Velocity is a 4 when time is a 7. This implies that 4 equals 7 square minus a 9 into 7 plus a c. So 4 equals 49 minus 63 plus a C, which means C is 18. Okay, so the velocity is actually t square minus a 90 plus a 18. Okay, find the times when the velocity is a 0. Well, I have the expression for velocity. I want to find out the time when the velocity is a 0. So I'm going to go equate this to a 0 and solve. So it comes out to be, I go split the middle term. So t minus 6 into t minus 3 is a 0, t is a 3 and a 6. So those are the two, t equal to 3 seconds and t equal to 6 seconds is the time velocities are, velocity is 0. Okay. Huh. Let's go do another thing now. Here. So they are like, at time equal to 12, the displacement of the particle from the origin is 150. They say displacement is a 150 when time is at 12. Find an expression for displacement. Okay, fine. I know displacement is supposed to be velocity integrated. Well, I'm looking at 9t square minus a 90 plus a 18 integrated. That would come out to be t cubed by 3 minus a 90 square by 2 plus a 18t plus a c. And the fact that s is a 150 when t is a 12, I'm going to use that to find out c. So 150 equals 12 cube by 3 minus a 9 into 12 squared by 2 plus a 18 times 12 plus a c. This means that c comes out to be, let's just quickly find out what it was. I don't have a calculator right now. Let's see. Six. C comes out to be a 6. Now the expression for displacement is going to be t cubed by 3 minus a 9t square by 2 plus a 18t plus a 6. Okay. Hmm. Okay. So I have an expression of displacement now. There. This is the one. That's your 3 marks. Okay, so that was the process of it. Let's go look at some other part. Okay, find the distance traveled by the particle. Well, this is where it gets tricky. Okay, distance traveled. So you've got the expression for displacement, and you're looking for the expression for, you're looking for the value of distance traveled. Okay, what I do is I figure out the displacement values at different time values. I'll be like s equal to 0. I know that the particle has turned when time is a 3 second from my previous part. See, when time was a 3 seconds, velocity is a 0. Well, that is an indication that the particle has turned. And it has turned again at time equal to 6 seconds. Well, I really don't, I can't go tell you that it has literally turned at those 2 points unless I find out the velocity values. But these happen to be critical points for sure. These 3 seconds and 6 seconds. These are critical points. So I'm going to go find out the displacement at those critical points. I'm going to go find out S3 and S6. All three of them. Okay. So S0, with that expression, with that expression of displacement, you can see substitute a t equal to 0, you get a S0 as a 6. Substitute a substitute a t equal to 3, you end up with a, let me see, 28.5, I remember. Yeah, 28.5. And s equal to at s equal when times a 6 is at 24. Okay, so you can see the displacement has reduced between 3 and 6. So there's definitely a turning happening at time equal to 3 seconds. Okay, let's draw the situation, okay, to find out the distance. Well, this is where I'm going to measure the displacements from when time was a 0, particle was 6 meters away. This is where you were when time was a 0. Then, when time is a 3, this is the displacement. So you went a little further away from that place, and this is where you are when time is 3 seconds, and the displacement now is at 28.5. And look at this critical step here. When you know that the displacement is at 28.5 when time is a 3, know that it's the distance measured from this place. That is a 28.5 meters. Displacement measured from a fixed point. It's a 28.5. That's what it is when time is a 3. And when you turn back, displacement now is a 6, so you turn back and go somewhere here maybe. And now the displacement is again from the same point. It's 24 meters. How many meters have you actually traveled in distance when they want to find out the distance? Well, this is where you started. This is how you go and turn back. Okay. So I'm going to go find out the length of that green thing that I have. Well, here the green thing is about 22.5 meters. And from 28.5 to 24, the length has reduced by 4.5 meters. So this thing is 4.5. This thing is 22.5. Overall, you've moved 22.5 plus a 4.5 are 27 meters. That is your answer for this question. So this diagram is important, okay? Knowing that the displacement is a 6, knowing that you were already 6 meters away from the point O when time was a 0. If that displacement is at 28.5 when time is a 3, this is the distance on the diagram you're talking about. So you've moved only 22.5 meters actually between 0 and 3. And if the displacement now is a 24, you've only moved 4.5 meters. This minus that, 4.5. Okay, so that was the question. Nice. So what can we do here? Um, 10th question, you should be good with the algebra part here. There was a 49 minus 6, 63. That's a negative 14. Take it to the other side, comes out to be 18. So one silly mistake here can cost you a lot. And find an expression for the displacement of the particle. This was the question and solution of it. Okay, let's go move to the last one. Is this the last one? Yes. Oh, binomial. Okay, nice. Let's see. Finding descending powers of x, the first three terms. Okay, so I go 9c0. You want descending powers. So you want x squared to have the maximum power first and 1 by 2x to have the minimum power first. That's your first term. So you go x squared to the power of 9 and 1 by 2x to the power of 0. That's where you have the term with the maximum power on x. The other one is going to be 9c1, x squared to the power of 8, and 9c2, x squared to the power of 7, 1 by 2x to the power of 2. Let me check what the answers are supposed to be. Okay, so this comes out to be x to the power of 18. This one is 9 by 2 x to the power of 15. And this one is 9x to the power of 12. Okay. Okay. Now, that was your question. Pay attention that they have asked for descending powers. That's not usual. They usually go ask you for ascending powers of x. This is descending power. So you should have this term first. X squared raised to a 9. Okay. Anyways, the expansion of this has a term independent of x. Okay. Show that n is divisible by 3. Okay. Okay. So I go find out any random term in that expansion. I know it's going to be NCR x squared to the power of n minus r and 1 by 2x to the power of r. Any random term. By the way, this formula NCR a to the power of n minus r and b to the power of r. That is given in your formula booklet. I'll show it to you. NCR, this is what any random term would be like. So I go try to isolate the x terms, okay? So open up this bracket. This is what you get on this one. And if you go expand the brackets for this one, this is what you get. Now, there's a x to the power of 2n minus 2r, and there is a x to the power of r. I'm going to go combine these two. How? Well, I know x to the power of a into 1 by x to the power of b can be written as x to the power of a minus b. Well, that's what I'm going to do. It's going to become x to the power of a, which is 2n minus 2r, minus a b. Well, that's x to the power of 2n minus 3r. Okay. Well, they say that there is a term which is independent of x. So what I have as the power on x here, this term with x with x with the power of 2n minus 3r. If it needs to be independent of x, 2n minus 3r should be a 0. It should have no x, meaning that that power should vanish. It should become a 0. So 2n minus 3r is a 0, which means n is a 3r by 2. Okay, fine. So 2n minus 3r is a 0. That's the power on x and it should vanish. Okay, which means n is a 3r by 2. Well, don't you see that n is 3 multiplied by some number r by 2? 3 multiplied by r by 2. That's what it is. N is 3 multiplied by r by 2. And what they wanted is for me to show that n is divisible by 3. Okay. If n is equal to 3 times something, and 3 is definitely a factor of n, which means n is divisible by 3. So you tell them clearly 3 is a factor of n, and so n is divisible by 3. Here you can tell them for term independent of x should be equal to 0, and okay, that's how that should be our working for it. Kind of a unique question. Never I've never seen a question like that. That's gonna make it a little difficult. But yes, that was the question paper. Uh, very nice questions. I would say um, it takes a lot out of you, this whole thing. But I was telling you about that thing. There, this is the formula I was talking about in the binomial expansion. NCR, a to the power of n minus r, b to the power of r. That's the formula usually given to you. Okay. So that was the whole paper. Hmm. What I'll do is I'll take screenshots of my working, and I'll also upload the link to the original paper for you to do it by yourself. Okay. And maybe after that, you can come back to these solutions or to this video. That's it. I'll see you soon. Bye. Have a good day.